The question that I proposed on Friday was, are did I say are boys better at making paper airplanes? Okay. So there's my question, and I'll put this formally in statistics. Do we have evidence that I'm not, I got in trouble sixth period saying boys, so males. Because one male in the room said, "I am not a boy, I am a man," and I went, "Okay, whatever."
See, the people who say that are the ones who are the least manly.
Yeah. You don't have
Then I guess I won't say who said it.
I bet you it's Alex DeBron. If people
No, it
know
wasn't.
you're manly, you don't have to say it to
Yeah, exactly.
Okay. So do we have evidence that males make better paper airplanes? And we, of course, did the test of distance of flight. There are other tests we could do, but distance of flight was a real easy one to do on this. All right. So they're all four-step procedures. So we'll do step number one. We'll define our parameter. Well, in these tests, we are comparing two populations, boys and girls, males and females. So I got two parameters here. Huh? What?
Trying to just ask, are all girls?
Are all girls females? Most of them are, yes. Yes, most girls are females. You will conduct a study, okay. Okay. So I've got two population parameters. So I'll call them mu sub m and mu sub f. And mu sub n is the mean distance male-made airplanes fly. I guess that's the way I'll say that. And mu sub f will be female-made. And I'll just put dittos. Okay. I need a null and alternative hypothesis. So my null hypothesis is usually about that there's no change, that there's no difference. So in this case, I'll say that there's no difference between the mean of the male-made airplanes and the mean of the female-made airplanes. So I'll call this mu sub m is equal to mu sub f. And I'll write over here in words no difference. Okay. Now my question was, do males make better airplanes? So my alternative hypothesis should be that the average distance for males is greater than the average distance for females. You may write the null and alternative hypotheses in this way, excuse me, or you can write it as, excuse me, the mean of the males minus the mean of the females is equal to 0. And for the alternative, the mean of the males minus the mean of the females is greater than 0. They mean exactly the same thing and are written in the same way. And this is not a different test when I write it in this notation. Yeah, those are. You'll see it both ways, so you should be able to interpret it both ways. Sometimes I like the first writing of it because when I think of what my null and alternative hypotheses should be, this kind of like reads more like the sentence that I'm thinking of. The males are equal to the females. The males are greater than the females. So I often write it that way first, but sometimes mathematically I need to write it the second way. It makes a little more sense to me. Valid. Okay. So, step 2. What are we supposed to do in step 2? Conditions and what? Name your procedure here.
So not name procedure before step 1.
You may name the procedure in step 1. You don't have. It doesn't matter where you put the 1s, 2s, 3s, and 4s. You only have to put down 1s, 2s, 3s, and 4s. But you do need to have your procedure named at some point. So this is going to be a significance test. Not for a population mean, but 2 population means. What distribution do you think we should use? YT. Don't know the population standard deviation. Okay, so this is on a T distribution. And these are 2 independent samples.
You kind of just say that.
Yeah, but I did not say independent, and that becomes so. We're okay to not repeat that, but I am going to stress the word independent. There's no E on the end. That was just my little writing there. Just because that will come up when we go to check conditions. Did we have a simple random sample of males and females making airplanes from the population of all males and females? No, we did not. What did we have? Did we have a fairly well-controlled and randomized experiment? All right. So you don't think it was very well randomized? We'll say, I tried.
Because AP stat students aren't necessarily representative.
I don't need a representative sample if I'm doing a controlled randomized experiment. And so we're not talking representative sample here. We are talking, did we have some, the most important part about this is the randomization. We had one person throwing the airplanes. And did they know what airplane they got? Whose airplane they got? Most of the time. In 6th period, they did a little better with their experiment. They didn't let the thrower know whose airplane they were throwing each time. Oh, okay. All right. Then I think we were well randomized there. And your airplane was the best one. Okay. That's good. All right. Normality. Do I have a large sample size? No, we had what? What's the sample size for the 15? For the males. Sorry, for 15. For the males. Females, sorry.
Females 13.
And the males?
12.
12. These are not large sample sizes. What do you do for a t-distribution if they aren't large sample sizes? Box plots. So we need to check the box plots of each one of these samples. Anybody got a box plot they can...
Females has one kind of big outlier.
Ooh, so, yeah, that's right. That was Jody's. How about the males?
Males has no outliers.
So we may not be meeting conditions very well. But we will proceed with caution. How about that? Or we could get rid of Jody's throw, but then that would, you know, like, we don't really want to get rid of Jody's throw because it was one of the best ones. It was the best of males and females, I think. Okay. My next